Assalamu alaikum everyone. I hope you guys are doing well. It's good to see you here. And yeah, exams are just around the corner. And abhi hum basically, this is the first stream of hopefully many streams. And the goal is to make sure that first of all, I'll try to go through the concepts जो कि usually separately grades में नहीं सिखाए जाते. I'll try to do that. And obviously the more important ones, I'm not saying कि सिखाए नहीं जाते, it's just that we usually try to like tend to overlook them क्योंकि कोई चीज़ हमें 9th में सिखा रहे हैं, कुछ 10th में सिखा रहे हैं, 11th में जा रहे हैं, तो by the time we are in grade 11 and just 2 or 3 months away from exams, so this might be something that we have overlooked. And not just that, it is also important because कई दफ़ा क्या होता है कि हमें वो चीज़ें सही तरह से even in grade 9 if you start with them, तो कई दफ़ा ऐसा होता है कि इफ़ यू नो दीज कॉन्सेप्ट्स एंड इफ़ यू आर लुकिंग एट थिंग्स फ्रॉम दिस परस्पेक्टिव कि अच्छा अभी एग्जाम्स हैं और ग्रेड 11 वाले आई विल बी मेनली डीलिंग विद, बट ग्रेड 9 वाले स्टूडेंट्स, ग्रेड 10 वाले स्टूडेंट्स जो इन चीज़ों को देख रहे हैं अभी एंड हु आर गोइंग टू स्टडी द सब्जेक्ट फॉर द नेक्स्ट 1 or 2 years, आई थिंक ये उनको भी काफ़ी इसमें फ़ायदा होगा. सो या लेट्स गेट स्टार्टेड. आज का टॉपिक इज़ एक्चुअली समथिंग दैट इज़ वेरी नियर एंड डियर टू मी. I was just thinking about कि अच्छा is there anything that we tend whenever we are studying chemistry हमें ऐसे लगता है कि यहाँ पे ये हो रहा है, यहाँ पे ये हो रहा है, इस चैप्टर में ये चीज़ है, इस चैप्टर में ये चीज़ है, and then suddenly it dawns on us कि अच्छा ये चीज़ तो वहाँ पे भी हमने देखी थी. So these connections कि हमने एक टॉपिक ग्रेड 9 में सीखा है, एक टॉपिक ग्रेड 10 में, एक 11 में सीखा है, are they really connected to each other? And then there are words that we use in chemistry जो कि we use them so much that they lose their meaning in a way. मतलब reaction हो रहा है, this thing is more reactive. What does it even mean to be more reactive, or what does it even mean to be more stable? We usually use words that mean the same thing और हम बस synonyms देते रहते हैं. जैसे हम कहते हैं कि something is more stable, तो अब उसका मतलब basically हम ये कहना चाह रहे हैं कि उसके noble gas configuration है, और noble gas configuration is important for electrons to achieve. तो हम उसको कहते हैं कि नोबल गैस कॉन्फ़िगरेशन का मतलब ये होगा कि वो ज़्यादा स्टेबल होगा. सो जस्ट लाइक दैट, व्हाट डज इट इवन मीन टू बी मोर रिएक्टिव फॉर एनी एलिमेंट? हम कहते हैं कि ये ज़्यादा रिएक्टिव है या वो कम रिएक्टिव है. व्हाट डज इट इवन मीन? अस्सलाम वालेकुम एंड या यू गॉट एन ए स्टार. माशाल्लाह माशाल्लाह, बहुत बहुत मुबारक हो. एंड इफ़ यू कीप वर्किंग then you will inshallah succeed. Yes, I love that channel by the way. So yeah, thank you for that reference. Good to see you, Hadi. Good to see you, Saim. Okay, so let's get started with reactivity. Usually, there is an idea in chemistry that you will see many times. The idea is that a more reactive species, and over here when I say species, it can mean ion, it can mean electron, it can mean atom. So I'm taking the atom here, or atom or molecule, displaces a less reactive species. Less reactive species, again, this one I'm going to talk about as ion. So basically this is like musical chairs. Okay, you have ion that is there and there is some stronger atom somehow, और वो आके उसकी जगह ले रहा है. How does it do that? So that is the main idea that I'll be discussing today. और मैं आपको दिखाऊंगा कि कैसे grade 9, 10, 11 इन सब में हमने different chapters different नामों से पढ़े हैं, but they're all exploring the same idea. It's all the same displacement principle. That's the name of this thing, displacement principle. Okay. डिस्टिंक्शन कैसे आती है? ऑनेस्टली डिस्टिंक्शन के लिए दुआएं चाहिए होती हैं. डिस्टिंक्शन मेहनत और दुआएं दोनों की एक बहुत ज़बरदस्त कॉम्बिनेशन से आती है. एंड आई विल नेवर रिकमेंड कि आप डिस्टिंक्शन के लिए तैयारी करो. आई वुड जस्ट से कि आप चीज़ों को समझने की कोशिश करो. ट्राई टू अचीव एक्सेलेंस इन दैट थिंग एंड वट एवर द सब्जेक्ट इज. और डिस्टिंक्शन इज़ जस्ट अ बाय प्रोडक्ट. डिस्टिंक्शन कभी आप उसके लिए, आई वुडंट रिकमेंड कि आप उसके लिए कोशिश करो. इससे बहुत सारे टनल विजन सा हो जाता है. आई हैव हैड स्टूडेंट्स अल्हम्दुलिल्लाह जिनकी डिस्टिंक्शन आई हैं, लेकिन उन्हीं स्टूडेंट्स के उन्हीं बैचेस में और भी बहुत से स्टूडेंट्स थे जो कि इक्वली स्मार्ट थे, इक्वली हार्ड वर्किंग थे. बस किस्मत की बात बहुत ज़्यादा है इसके अंदर. सो आई वुडंट से कि आप डिस्टिंक्शन के लिए ट्राई करो. ऑन द रिस्क ऑफ साउंडिंग क्लीशेड, आई वुड से कि एक्सीलेंस का पीछा करो. ये चीज़ें distinctions, awards या ये चीज़ें खुद ही मिल जाती हैं. Okay, so this is displacement principle, and that is what our discussion today will be hovering around. कि displacement principle क्या होता है? That a more reactive species displaces a less reactive species. And you will see कि बहुत से reactions में, बहुत से chapters में same ideas come to our like they represent themselves but in different ways. Okay, so let's get started. A couple of things before we do that. For those of you who are in grade 9 जिन्होंने अभी इन चीज़ों को नहीं देखा है, redox reactions क्या होते हैं? Reduction is the name of when something gains electron. So when something accepts electron, that is called reduction. And when something donates, या इसको हम एक और word use करते हैं, loses electron, that is called oxidation. These are two words that we will usually use. अब होता क्या है कि in grade 9 we learned this in a very simplified format कि metals lose electrons and non-metals gain electrons. And that works with us in many cases. But examiner को भी इस बात का पता है कि students रटा मारते हैं और वो समझते हैं कि जी metals हमेशा lose करेंगे and non-metals हमेशा gain करेंगे. And today I'll show you that that's not always the case. There are non-metals that will lose electrons. And there are metals that will gain electrons. And to make things even weirder, there will be non-metals giving electrons, losing electrons to metals. And that is something जो हमें काफ़ी surprise करती है when we first encounter it. And sometimes we don't even recognize it when it is there. Okay, so reduction is accepting electrons and oxidation is losing electrons. अगर कोई चीज़ gain करी है electrons को हम कहेंगे कि ये चीज़ reduce होगी है, और जिसने उसको electrons दिए होंगे उसको हम बोलेंगे ये reducing agent है, क्योंकि उसने उसको reduce किया है ना. So that is a reducing agent. Similarly, when something gains electrons, we say it is when something loses electrons, we say it is oxidized, and जिसने उससे electron लिए होंगे, we'll call that an oxidizing agent. Okay. Now, same idea of metals and non-metals when we apply over here. So metals को हम कहते हैं they lose electrons. So based on this, metals are reducing agents, and non-metals they gain electrons usually. So that shows कि non-metals are oxidizing agents. अब हम ये देखें कि is it always the case कि कोई reducing agent होता है और कोई oxidizing agent होता है? क्या ऐसा नहीं है कि something is better at being a reducing agent and it sucks at being an oxidizing agent? कैसा ऐसा होता है? या कोई चीज़ हमेशा reduction करती है और हमेशा oxidation करती है? ऐसा नहीं है. It's always a spectrum. It's always a comparison that these things have. And that is the main point that I want to show to you today. अब फिर हम क्या करते हैं कि हम इन चीज़ों को याद करने के लिए there is a reactivity series that we have. And in the reactivity series, this is usually the one that we have for O levels and IGCSE. We have start with potassium, sodium, calcium, magnesium, aluminum, zinc, और इसके बीच में हमारे पास कार्बन है, ठीक है, आयरन, lead, hydrogen, copper, silver, and gold. This is usually the reactivity series that is useful for us in O levels. Yeah, IGCSE में. Similarly, for non-metals, we have another one, which is sulfate, nitrate, and at the top we have fluorides or fluorine, and then we have hydroxide, fluoride, chloride, bromide, iodide. Sometimes ये hydroxide जो है ना ये यहाँ पे भी होता है, like right at the end, and that is fine. Sometimes हम इसको ऊपर रखेंगे, and I will work with this one, the one where hydroxide is above chlorine. अच्छा, and we say कि ये reactivity series है, and the things at the top they are more reactive, and the things at the bottom they are less reactive. अच्छा, आती कहाँ से reactivity series? Is there any main ideas that are behind this reactivity series being there? मतलब कैसे बनती है? And how do we figure it out? Is there any experimental evidence for this? So इसको करने के लिए I did a couple of experiments and I will show them to you as well. अभी like I'll show you the videos of those results. But let's look into this. Potassium is in group 1. How many electrons does potassium lose? 1. Sodium is in group 1. It also loses 1. So why is it that potassium ऊपर है और sodium नीचे है? Let's look in the periodic table. In the periodic table, if you look at the period, potassium is in period 4 and sodium is in period 3. Okay, is this the reason? Let's see. आगे चलते हैं. Calcium is in group 2 and so is magnesium, group 2. Calcium is in period 4, magnesium is in period 3. Okay. Aluminum is in group 3. Okay, and it's also in period 3. Period 4 में aluminum से आगे जो elements हैं, we don't consider them in O levels or IGCSE. हम calcium से आगे नहीं जाते. There's something happening here. 1, 2, 3. It can't be a coincidence कि कोई चीज़ जो 1 electron lose कर रही है, it's the most reactive. जो चीज़ 2 lose कर रही है वो उससे कम है, और जो चीज़ 3 lose कर रही है वो उससे भी कम है. क्यों हो रहा है ऐसा? Because losing more electrons or involving more electrons requires more energy. So जितनी ज़्यादा energy चाहिए होगी उतने कम reaction होगा. So aluminum needs to lose 3 electrons, तो वो कम reactive है. Magnesium needs to lose 2 electrons, वो ज़्यादा reactive है. And that is how we see it. The reactivity series actually talks about the group numbers. कि अच्छा वो ग्रुप नंबर 1 में है तो उसके पास 1 इलेक्ट्रॉन लूज करना है, ग्रुप नंबर 2 में है तो 2 इलेक्ट्रॉन लूज करना है, 2 वाले को ज़्यादा एनर्जी चाहिए, इट मेक्स इट लेस रिएक्टिव. सो एट द हार्ट ऑफ इट व्हाट इज रिएक्टिविटी? रिएक्टिविटी इज द एनर्जी दैट यू हैव टू स्पेंड टू बिकम वट एवर यू वॉन्ट टू बी, राइट? वट एवर द एलिमेंट ट्राइज टू बी, कैटाइन और एनाइन या जो भी करना है. सो इट हैज़ टू डू विद द ग्रुप नंबर, ये कितने इलेक्ट्रॉन इन्वॉल्व हैं. एंड देन what about this 4-3-4-3 pattern? So what is the main idea that changes in an atom? Atom को क्या फर्क पड़ता है when it changes to different periods? So potassium has 4 shells. So जब potassium के electrons get involved in reaction, they are removed from period group 4. In the shell number 4. तो potassium का बड़ा atom है. Sodium's electrons are in period 3 यानी कि shell number 3. So उसके sodium's electrons are in the 3rd shell and potassium's electrons are in the 4th shell. So the attraction that sodium has to its last shell is stronger. The attraction that potassium has to its last shell, that is weaker because it's a bigger atom. So atomic radius plays a role here. So हम कह सकते हैं that bigger atoms have weaker attraction to valence electrons. And because valence electrons are the only ones that take part in a reaction, these bigger atoms will have what? They will be more reactive if they want to lose electrons. So they are better at oxidation. They need less energy to do that, and because they need less energy, they're more reactive. So इसका मतलब है कि they're better at oxidation. तो इसका मतलब ये भी होगा कि they are worse at reduction. And yeah, that is true. Let's look at the non-metals. In the non-metals, we have fluorine right over here, which is a really, really small atom. And then we have chlorine, bromine, and iodine. Iodine is a really, really big atom. Iodine is in period 5. 5 shells हैं उसके पास. So it will be very difficult. It will require a lot of energy कि iodine electron gain करे. क्योंकि बहुत दूर है ना valence electron. But fluorine का, it's right around the corner, 2nd shell. So वो electron जल्दी gain कर लेता है. And that is how we can see कि valence electron करीब होने से it becomes easier to gain it. और valence electron दूर होने से it becomes easier to lose it. So should metals do it? If calcium is in period 4 और उसके पास चौथा शेल में इलेक्ट्रॉन है जिसने रिमूव करना है, तो कैल्शियम को उसको लूज करना आसान लगेगा. और मैग्नीशियम के पास 3rd शेल में इलेक्ट्रॉन है जो उसने लूज करना है, उसको लूज करना कैल्शियम की निस्बत मुश्किल है. बट व्हाट इफ आई वर टू रिवर्स इट? What if I were to force magnesium to gain electrons? Will magnesium find it easier to gain electrons? Of course. Magnesium is a smaller atom. So उसकी attraction to the valence electron is stronger. And that means that magnesium is better at gaining electrons than calcium. अब यहाँ पे आप कह सकते हैं कि metals तो gain नहीं करते हैं. But if you have ever charged anything. अगर आपने कभी बैटरी फ़ोन की चार्ज की है या आपने सेल्स यूज़ किए हैं रिमोट कंट्रोल वाले, इफ़ यू हैव एवर प्लेड विद अ कंट्रोलर, PS4 का PS5 के कंट्रोलर से आपने अगर उसको चार्ज किया है, you have actually given electrons to metals, and that is nothing new for us. All the batteries in the world make use of this idea that metals lose electrons if they're more reactive, but metals gain electrons if they're less reactive. More reactive things in metals, they are better at losing electrons, and less reactive metals are better at gaining electrons. So now we shouldn't look at reactivity series as that this becomes less reactive down the group. It simply means that down the reactivity series, they are better at reduction. इलेक्ट्रॉन गेन करना आसान है एंड ऊपर जाते हुए इलेक्ट्रॉन लूज करना आसान है. तो हम कह सकते हैं कि दिस इज काइंड ऑफ लाइक एन ऑक्सीडेशन सीरीज. And this one on the right side, it is the reduction series. Assalamu alaikum. This is reactivity series, metals, ionic bonding, many things that I'm going to touch upon today. It is one principle that you will see throughout. Reactivity series के साथ साथ हम start कर रहे हैं, but we will see कि कहाँ कहाँ ये आता है. Salts में भी आता है. So हम कह सकते हैं that this side is oxidation series and this is reduction series. और हो क्या रहा है कि जैसे जैसे आप नीचे जा रहे हो, इट बिकम्स ईजियर टू गेन इलेक्ट्रॉन एंड डिफिकल्ट टू लूज इलेक्ट्रॉन. और जैसे जैसे इसमें आप नीचे जा रहे हो, इट बिकम्स ईजियर टू लूज इलेक्ट्रॉन्स बट डिफिकल्ट टू गेन इलेक्ट्रॉन्स. तो उल्टा चल रहा है. ठीक है. सो इन द ऑक्सीडेशन सीरीज, द मेटल वन, जो पोटेशियम, सोडियम, कैल्शियम, जिसको याद करने के लिए हम कहते हैं प्लीज सेंड कैट्स, मंकीज एंड जीब्रास इन लार्ज हेवी केजेस and something else, I've forgotten it. Yeah, but there are many other mnemonics that you can use. So okay, so atomic structure से हमें पता लग रहा है कि if something has more electrons to lose, तो वो ज़्यादा जल्दी oxidize होती है और ज़्यादा जल्दी reduce होती है और less effectively oxidize होती है. And if it's a bigger atom, it finds it easier to lose electrons. Okay, does this hold true for metals and non-metals? Yes. Non-metals में group 7 में आप देखोगे कि अगर ऊपर है, छोटे शेल्स हैं, तो वो जल्दी इलेक्ट्रॉन गेन करता है, तो वो ज़्यादा रिएक्टिव हो जाता है. एंड अस्सलाम वालेकुम अली. एंड इफ इट्स अ बिगर एटम, तो वो इलेक्ट्रॉन उतनी जल्दी गेन नहीं कर सकता. तो आयोडीन और फ्लोरीन की एग्जांपल ले लो आप. और मेटल्स में इफ इट इज़ कैल्शियम, तो इट इज़ ईजियर टू लूज इलेक्ट्रॉन्स कंपेयर टू मैग्नीशियम, इवन दो दे बोथ हैव टू लूज 2 इलेक्ट्रॉन्स. ओके, all right. Now, first important placement of this idea is in extraction of metals. In extraction of metals, what we do is कि हमें, let's suppose, copper oxide मिलता है. It's a black rock. We find it. हमें इसमें से copper निकालना है. Copper is something that we use. Copper oxide कितना ज़्यादा use नहीं है. So what will we do? We will look for something कि यहाँ पे copper जो है, it is in positive 2 and oxide is negative 2. So copper has lost 2 electrons. अगर मुझे इससे somehow मुझे copper चाहिए, so this one is copper 0. That means that I want copper ion here to gain 2 electrons, and that is how it will form copper element. I want it to gain electrons. So I need something जो copper को electron दे. Anything that is better at losing electrons, and that means copper is better at gaining electrons. Let's go back to the series. Copper is over here. That means this and everything above is better at losing electrons than copper. And that means copper is better at gaining electrons than all of these. And in all of them, hydrogen is the nearest neighbor that we have. We could use carbon, we could use zinc, iron, कुछ भी use कर सकते हैं, but hydrogen offers certain advantages. मतलब hydrogen gas है, gas का spray करेंगे पूरे copper oxide के ऊपर, react कर जाएगी, metal वगैरह को हमें mix करना पड़ेगा, so easier to do. So अगर मैं copper oxide में hydrogen add करता हूँ, so क्या होगा? Hydrogen being a gas, and hydrogen is better at losing electrons. Remember, it's higher up in the reactivity series. And copper is lower in the reactivity series. Copper को वो electron दे देगी. And it will form positive ion. Now, oxide is a negative ion. It's interesting, right? So a non-metal giving an electron to metal. Let's continue this. Do we see it anywhere else? Let's say I have iron oxide. Iron oxide is another rock that we find. This one, we find it in hematite. It's a red-brown rock. ये color भी आपको याद होना चाहिए. And then, is there anything? So again, what's happening here? Iron has a +3 charge, oxide is -2. मुझे इसमें से pure iron चाहिए. Which means इसके ऊपर 0 charge होना चाहिए. मुझे iron को are more reactive than iron. So here's what will happen. All of these can give electrons to iron. So iron will gain them. Let's say इनमें सबसे I could use zinc, I could use carbon, I could use any number of these things. Aluminum use कर सकता हूँ. But carbon is the cheapest one. It's the most easily available. और high quality carbon को हम coke कहते हैं. So I will simply take coke and I'll react it. And this will form carbon dioxide. Why? Because carbon and oxygen will react and I'm able to displace iron from here. It has a little more than just transfer of electrons. Sharing भी होती है. काफी इसके अंदर reaction है. That we don't need to go into, like iron oxide completely ionic भी नहीं होता. But we don't need to go into that. The main point is that iron is better at gaining electrons than carbon in this series. So we'll balance this equation 2, 3, 4, and 3. There you go. Okay, does it apply to something else? Of course it does. You bet it does. Zinc, which is recently added to the syllabus, I think this will be the first year कि वो O level के syllabus में आएगा. IGCSE के syllabus में काफी सालों से. So zinc sulfide is what we find it in nature. This is called zinc blend. Again, you need to know these names. अब zinc blend जो है, इसको मैं carbon से react कर सकता हूँ. क्यों? Zinc के ऊपर +2 charge है. Anything that is better than zinc or better at giving electrons at least, ये सब के सब जो हैं ये zinc को reduce कर सकते हैं. ये सब के सब electrons lose करने में zinc से ज़्यादा बेहतर हैं, and zinc is better at gaining electrons from all of them. But again, we can use carbon क्योंकि वो carbon काफी सस्ता है and will save us a lot of money, especially if you're doing it in a factory. So we can use carbon, but एक problem है. When I react it with carbon, I'll get CS2, which is a liquid and difficult to filter out later on, और उसको ख्याल करना, उसको separate करना मुश्किल हो सकता है. What can I do? I don't like it. What do you do if you don't like it? Here's an idea. In copper oxide, we had oxide. In iron oxide, we had oxide. Can we make an oxide here? Yeah, why not? Here's what we are going to do. हम इसको आग लगा देते हैं. We'll burn it. Combustion happens, reaction with oxygen. It will form zinc oxide and sulfur dioxide. काफी फायदे का reaction है. क्यों? Sulfur dioxide, I shared the notes of this in the group yesterday, so make sure that you go through them. If you're not part of the group, make sure that you join it. The links are there on my YouTube channel. Just go to posts, वो पहले वाला जो आपको मिल जाएगा link. Rapid revision groups, join them, and they are very, very helpful. Inshallah, we'll get the good grades that we're looking for. So rapid revision group, I shared notes for this yesterday. But if you have read them, then you know that sulfur dioxide is an acidic gas. And not just that, it's not just any random acidic gas. It's actually a very useful acidic gas because we use it to bleach wood pulp. So you can sell it to paper industry. Similarly, if you have made sulfur dioxide is a very antiseptic, good antiseptic. It can kill bacteria. So what you can do is you can give it to food packaging industry and they will use it to basically package food. तो उसके बैक्टीरिया को ख़त्म कर देंगे and they can easily use this. So food जो cans होते हैं खाने के उनमें sulfur dioxide. So you can actually sell this off. And now we are left with zinc oxide. So zinc oxide लेंगे, we'll react it with carbon now, and we're going to get carbon dioxide and zinc, and we have gotten it. In fact, to separate zinc here, zinc is I think it's the only metal that we extract in the liquid form. High temperature होता है ना, तो उसकी वजह से zinc becomes a liquid. It has a low melting point, so we are able to get it as a liquid. So there you go. We are able to use the idea of reactivity series to get this. Yes, Taha, the whole AS syllabus is completed. I will share the videos for past papers in the coming month. Okay, so we are able to do it for metals and reactivity series. The idea of gaining electrons and losing electrons for metals is showing it up. Similarly, अगर आपको sulfur dioxide को you don't want it, then what you can do is you can use flue gas desulfurization. That's also a process that was recently added to the syllabus, and I would suggest again go to the notes. I've posted everything in there. All right, so what we have this, we are able to extract it. Is there any other way through which we can confirm कि metals electrons gain करते हैं? Yes, cells. We call them electrochemical cells. The construction of this cell is not in your syllabus anymore, but इसके ऊपर reactivity series का question आ सकता है. Cell का question अब नहीं आएगा, reactivity series का question आएगा. So let's see electrochemical cell क्या होता है. Electrochemical cell में होता ये था, you have some electrolyte, some liquid that conducts electricity. Let's say मैं इसमें यहाँ पे zinc और copper, ये zinc है और ये copper है. I take that और मैं इनको simply एक wire से connect कर देता हूँ. What will happen? Simple question. I connect two metals like this. If you go in the reactivity series, copper नीचे है, zinc ऊपर है. Zinc is better at losing electrons. Copper is better at gaining electrons. जो चीज़ नीचे है, it's better at gaining electrons. जो चीज़ ऊपर है, it's better at losing electrons. So zinc अपने electrons lose करता है और उसके electron यहाँ से flow करके copper में आ जाते हैं. Now, in this year, they're going to change this a little bit. They're not going to ask you about the cell. Instead, what they can ask is, okay, let's suppose मेरे पास ये copper sulfate है. What will happen now? Let's see, copper sulfate, and I add zinc to it. Zinc is better at losing electrons. Copper is better at gaining electrons. So copper यहाँ पे, if I look at the charges, zinc can give electrons to copper and copper will accept them. So copper accepts the 2 electrons and makes copper metal, and zinc loses it and makes zinc sulfate. Let's look at the colors. Zinc is gray, copper is pink, copper sulfate is blue. What will happen to the blue color here? So this thing is blue, but what will happen now is that this blue color will fade. The blue color fades. This is an observation. 2 mark का question आ सकता है. Secondly, zinc solid है, but now it has formed ions. So solid में ions नहीं होंगे यहाँ पे. They are going to dissolve into the solution. So zinc solid dissolves. That's another thing you will see. And you will also see copper pink solid form. तो एक layer of pink solid बन जाएगी इसके ऊपर. So pink solid deposited. This shows you can use colors to figure out what is more reactive, what is less reactive. A more reactive substance will obviously dissolve in this case. So we can see that less reactive substance हमारे पास atom के in the form of solid आया था. So less reactive substance shows its color at the end of the reaction, usually solid for metals. Of course mercury होगा तो वो solid नहीं होगा at room temperature. See, so you are getting Yeah, you are getting a less reactive zinc solid at the end. And that's interesting. Oh, sorry, less reactive copper solid at the end. और उसका color pink है. So you're able to get that here. Does the same thing apply to non-metals? It does. Group 7, group हमने periodic table में grade 9 में पढ़ा होता है. Group 7 में I have fluorine, chlorine, bromine, iodine. If I look at these, fluorine का color क्या है? Yellow gas. Chlorine, yellow green gas. Bromine, orange or red brown liquid. And iodine, black solid. But not just that, iodine is actually brown liquid and purple gas. These colors हमें याद करने हैं. And again, the colors are in the notes that I've shared with you. Now here's the thing, fluorine is in period 2, छोटा atom है. इसकी attraction very strong होगी. Iodine is in period 5, काफी बड़ा atom है. इसकी attraction weak होगी valence electron से. इसका मतलब ये हुआ कि iodine is better at losing electrons and fluorine is better at gaining electrons. छोटा atom है, attraction strong है, it can easily gain electrons. So fluorine can easily reduce and iodine can easily oxidize. Okay, so that's the case here. Let's see क्या होगा. I take hydrogen iodide. This is not dissolved in water, so right now it's hydrogen iodide. But the moment I dissolve it in water, it becomes hydroiodic acid. Okay, so we have hydroiodic acid. I don't know your name, number one gaming, but yeah, do you have a question? Now hydroiodic acid jo hai, if I add, let's say, bromine to this, orange color hona chahiye uska. But the moment I add it, this becomes HBr and it releases iodine as a iodine उसमें से बाहर आ जाती है. क्यों? Because iodine के पास negative charge है, bromine के पास 0 है और यहाँ पर bromine has lost electrons and sorry, bromine has gained electrons and iodine has lost electrons. From here to here, iodide has given its electron away, oxidize हो गई है, and bromine has accepted the electron, which is exactly what we talked about. Smaller atoms are good at gaining electrons. Bigger atoms are good at losing electrons. Non-metal is losing electrons. Again, this is something new for us. हमने इसको कभी ऐसे देखा नहीं है. So iodide is non-metal losing electrons and bromine is gaining electrons because of its size. और हमें brown color end पे मिल जाएगा iodine का. Let's say I take this HBr. By the way, what is hydrogen doing in all of this? Hydrogen is positive, तो जो भी चीज negative है वो उसके साथ bond कर रही है. If I add chlorine to this, so उसका green color है. I should see that, but that's not what I see. What happens is that Br is minus and chlorine is 0. Chlorine is a smaller atom, better at gaining electrons. Bromine is a bigger atom, better at losing electrons. So bromide here gives its electron to chlorine. Chlorine से electron gain कर लेता है. And now you're able to get HCl plus Br2. And you will see orange color or red brown color of bromine that shows up. Not just in metals, but also in non-metals. Same ideas apply. Okay, so that's another way we can figure out what's more reactive. First of हमने देख लिया bigger atoms हैं, and then we said कि atomic size के अलावा हमारे पास color से भी पता चल जाता है कि something is more reactive or something is less reactive. And within the same group, of course, atomic radius से बहुत ज़्यादा फर्क पड़ता है. But what do we do in case we don't have colors? Transition metals show their colors, but other metals, they're all just what? Gray, your silver, उनके colors नहीं हैं, उनके solutions के colors नहीं हैं. So how do we differentiate between them? So for that, we have the idea that more reactive elements. Again, what is reactivity? It is how fast or slow something can involve electrons. So electrons are the thing that they're buying. And what are they spending? Energy. So if something gives electrons or something gains electrons, उसमें energy involved है. And जितनी ज़्यादा energy involved है, उतना वो कम reactive है, उतनी वो बुरी deal है, उतनी activation energy ज़्यादा है. So if you need to spend less energy, that means it's more reactive thing. So more reactive substances, what are they going to do? अगर एक more reactive है, एक less reactive है, the more reactive one will react with lower activation energy. उसको एनर्जी कम स्पेंड करनी पड़ेगी. दैट मीन्स उसको टेम्परेचर ज्यादा नहीं चाहिए एट लोअर टेम्परेचर्स. इज इट? लेट्स सी. इमेजिन इफ आई हैड जस्ट वाटर, और मुझे वाटर से पता करना है कि कोई चीज रिएक्टिव है या नहीं रिएक्टिव. सो इज व्हाट आई कैन डू. आई कैन टेक कोल्ड वाटर. पोटेशियम रिएक्ट्स विद कोल्ड वाटर. मैग्नीशियम डजंट. If it does, बहुत slow reaction होता है पोटेशियम की नस्बत. It's a comparative thing. Iron does not react with cold water at all. बहुत ज़्यादा slow reaction, मतलब आप देख नहीं पाएंगे, हफ्तों बाद वो reaction होता है. So that speed is telling me a little bit about what is more reactive. So I can also say that the one that is more reactive reacts with at higher rate. Same time में कौन जल्दी react कर रहा है, ज़्यादा react कर रहा है. That shows it's more reactive. So if I add potassium to water, it will be an explosion. That means higher exothermic reaction. But if I add magnesium to water, it's not that exothermic. It's slow, it's not that exothermic. Now, that means I can use water and the temperature of water to figure this out. If something reacts with cold water, so वो बहुत ज़्यादा reactive है. Something reacts with hot water, वो उससे कम reactive है. And if something reacts with steam, वो उससे भी कम reactive है. क्योंकि वो steam के साथ react कर रही है, which has a lot of energy, but not with hot water, which has relatively less energy. Is that the case with metals? You bet it is. Potassium, sodium, calcium, magnesium, they react with cold water. But after that, they don't. Aluminum does not react with cold water. You need to give hot water for aluminum to react. And then you keep on continuing, and that's not the case. Like you keep on continuing with aluminum, or aluminum में क्या होता है कि aluminum, hold on, somebody's message. Yeah, Assalamu alaikum. Assalamu alaikum Mustain. Good to see you here. अच्छा सर मुस्ताइन, कैसे हैं आप? Good to see you here. Okay, so basically, if you look at this, cold water, hot water, steam, it's only a way for us to figure out कि किस में energy ज़्यादा है, किसको energy ज़्यादा चाहिए. जिसको energy ज़्यादा चाहिए वो steam के साथ react करेगा, वो कम reactive है. जिसको energy कम चाहिए वो cold water के साथ react करेगा, वो ज़्यादा reactive है. And is that the case in metals? Yes, it is. Potassium, sodium, calcium, magnesium, ये जो ऊपर वाले सारे हैं, ये cold water से react करेंगे, और इसके बाद वाले hot water से react करेंगे, और ये steam से react करेंगे, और copper बिल्कुल react नहीं करेगा. क्यों नहीं करेगा? Hydrogen. Water has hydrogen. Water में hydrogen है जिसने electron gain करना होता है. ये सब hydrogen को electron दे सकते हैं. हाँ, energy ज़्यादा चाहिए to do that. Lead steam के साथ इसलिए react कर रहा है क्योंकि उसको ज़्यादा energy चाहिए to lose that electron to hydrogen. But sodium cold water के साथ react कर रहा है because it can easily give that in to hydrogen without spending a lot of energy. But copper can't. Copper electron ले सकता है, hydrogen से दे नहीं सकता. It is better oxidant, oxidizing agent. Hydrogen is a better reducing agent. And that is why we see them. So we can use the temperature of reaction of water to figure out if a metal is more reactive or not. Interesting. Now what about acids? With acids, you will see that potassium, but iron will merely react. Acids at all. बिकॉज कॉपर हाइड्रोजन के नीचे है, इसने हाइड्रोजन से इलेक्ट्रॉन लेने हैं, दे ही नहीं सकता. So the reaction slows down. So reaction slows down the series. Why? Because the closer you get to hydrogen, the gap that you have in terms of the energy that you involve, the energy that you need to do this reaction. Okay, hydrogen को electron transfer. We have copper जो कि बहुत ही slow है. So as we will compare them in terms of energy. So for group 1, here's what we can do. Group 1 के case में, because we know कि उनके solutions के colors नहीं होते. So for group 1, what do we do to figure out which is more reactive and which is less reactive? All you have to do is you take sodium, you add it to water. Water में H positive है. It can gain electron. Sodium can give electron. H नीचे, sodium ऊपर है. Sodium will give electron to hydrogen. And that is what happens. Sodium makes sodium ion. And hydrogen makes hydrogen gas. और OH minus इस positive ion के साथ react करके sodium hydroxide बना देता है. We call it displacement. Sodium has lost electrons to hydrogen. And that is okay. What do you see in this case? हमारी observations क्या होती हैं? First of all, let's look at the state symbols. कि वो ऐसे it darts around because वो float कर रहा है, but then move क्यों कर रहा है? Because there's a hydrogen gas coming out. The bubbles of hydrogen that come out, but then they're colorless. Every time, and this is important for ATP, every time you write कि गैस आ रही है, आपको ये भी बताना है कि वो कौन सी गैस है. और आपको कैसे पता चलेगा किसी भी गैस का? You see the bubbles, they don't tell you. उन्होंने कोई flag नहीं होता उनके ऊपर, कोई label नहीं लगा होता कि ये कौन सा गैस है. So you always mention bubbles of gas that pops in a flame. So we can see that this is a gas that pops in a flame. You can clearly see कर सकते हैं. अगर कंडक्टिविटी से पता चल रहा है तो हम यूज़ कर सकते हैं. अगर pH से पता चल रहा है हम उसको यूज़ कर सकते हैं. टेम्परेचर से पता चल रहा है हम उसको यूज़ कर रहे हैं. हमें इतने मेथड्स हैं to figure out what is more reactive, what is less reactive. And in सब के होते हुए, if we still choose to ratify, तो फायदा. Chemistry is all about concepts. Chemistry is all about practicals. And इतने methods हैं, रट्टे की हमें कोई ज़रूरत नहीं है. And in the next 2 months, हम रट्टा नहीं लगाएंगे. We will make sure that we build our concepts and we will solve the question.